Welcome back. In this video we are going to talk about properties of Laplace transform. So we are going to assume A, B and C, these numbers denote, these are constant, and by Fs we will denote the Laplace transform of Ft. Okay. Now you remember the definition of Laplace? Laplace is defined using the integration, and integration is linear. So the first obvious property is linearity. If you take Laplace of two functions, so Laplace of f plus g is same as Laplace of f plus Laplace of g. Take the Laplace of individual functions and add them up. Second important property is the shifting property. The shifting property is Laplace of e power at ft is equal to f of s minus a. So this function capital F denotes the Laplace of f. So basically you are shifting the Laplace of s by a unit if you are multiplying ft by e power at. Okay, this is very useful property. And the third important property is the second shift. The second shift, and this property is very useful when we are dealing with, so this property is useful while dealing with piecewise defined functions. And this property says, so if you remember when we were making the table of Laplace transform, we talked about Heaviside function, and I said that Heaviside function are important when we are dealing with piecewise functions, and this property is also important while dealing with piecewise functions. And this property says Laplace of f of t minus a times Heaviside function of t minus a. So we are using the Heaviside function over here is equal to a power negative as Laplace of ft. Okay. The second bit, very similarly, we can also talk about Laplace of ft times Heaviside function of t minus a. Here instead of f of t minus a we have ft. So this is e power negative a s same Laplace of f t plus a. Okay. So this is our second shift property. Next important property is the scaling property. what does this scaling property says? So if you have Laplace of f time of ct, where this c, as we decided, is going to denote a constant, is same as 1 over c Laplace of f, sorry, Laplace of ft. This is the scaling property. It should be, I think it's Laplace of t over c. 1 over c Laplace of f of t over c. Okay. Next property is, so here I'm going to list down all the properties, so you have all the properties together at same place, and whenever we need, we can go back, we can refer to this property. So these properties and the table are going to be very, very useful. You should always keep them with you whenever you are dealing with the problems, whenever you are solving the problems on Laplace transform. The next property is about differentiation. Obviously, we started studying the Laplace transform to solve our ODEs. So there should be something which relates the Laplace and the ODEs, right? So here we are going to relate the Laplace and the ODEs. So by small gt, the Laplace of small gt, we are going to denote it by capital GS. And let's make a table over here to have everything at one place. So in the first column we are going to write down the function, and in the second column we will write their Laplace transform. If we have derivative of a function g prime t, its Laplace is s times gs, where gs is Laplace of g, minus g of 0, the value of g at point 0. The Laplace of second derivative is equal to s square g of s minus s times g of 0 minus, only the first term here is positive, all other terms are negative, g prime 0. Similarly, the third derivative is going to be, so if we have third derivative, we start with s cube. First term is s cube gs, second term is s square g of 0, third term is s first derivative at 0, and the last term is g double derivative at 0. Let's generalize this. So if we are talking about the nth derivative, the Laplace is going to be s power n g of s minus s power n minus 1 value of g at 0, and so on. And the last term will be, so the second last term, let's write down the second last term, is going to be s times the n minus 2 derivative at 0, and the last term then is equal to g n minus 1th derivative at point 0. That's going to be our last term. It's very, like, if you see this table, it's very easy to remember, right? Okay. So this is how we connect the derivatives with the Laplace transform. The last property we are going to discuss is integration. How integration is related to Laplace transform. So if we take the integral, if we take the Laplace of a function 0 to t, the limits are from 0 to t, f of z dz, it's equal to f of s, the Laplace of s, the Laplace of f divided by s. Okay. So these are 6 very useful properties of Laplace transform we listed here. I encourage you to prove all of these properties. These properties are very similar, like you can prove them using the definition. So it's your exercise to verify above properties. And once you are done, you can check your notes also. All the proofs I have included in your notes, but I encourage you to first prove them by yourself. Okay, and we'll see in the next video. We will talk about how we can solve the ODEs using the Laplace transform. Bye bye, see ya.